All right, hello and welcome guys. In this video we are going to be covering if-then statements and converses, and you should be following along with those guided notes. All right, so we're going to just start off by taking a look at an example of an if-then statement. So we have if x equals 6, then x plus 2 equals 8, and that makes sense, right? 6 plus 2 is 8. So this is going to be true. In red here, this if x equals 6, that x equals 6 is known as our hypothesis. All right, you guys might remember hypotheses from your science class. It's like what you predict is going to happen. In this case, we're saying, all right, well, x equals 6 we know to be true. This is our hypothesis. And then in blue, this is our conclusion here. So we're saying if the hypothesis, if the hypothesis is true, then the conclusion has to be true. All right. And many times we see the hypothesis is just denoted by the letter P. Okay, you might think it's the letter H. That's not true. It's the letter P, and then our conclusion is denoted by the letter Q. And these if-then statements are sometimes just called conditional statements. All right, so if-then statements are also known as conditional statements. All right, that's the same exact thing as an if-then statement. All right, conditional statement. And so now we're going to talk about the converse. So if we have some conditional statement, let's say that I'm talking about my conditional statement, and we know it's if some hypothesis, then some conclusion. Well, my conditional statement follows if P, then Q. Right? This is really just our general form of the conditional. Well, our converse then, we're just going to flip the two. In the converse, we say if Q, then P. All right, so we flip the hypothesis and the conclusion. All right, let's take a look at this in an example. All right, and before we get to that example, we want to talk about just proving statements false. Okay, in order to prove statements false, we have to use a counterexample. So we use a counterexample to prove statements false. All right, and let's see these in an example. So here's my conditional statement that we start off with. If Ed lives in Texas, he lives south of Canada. That makes sense, right? We know that Texas is south of Canada, so obviously Ed lives south of Canada. Let's try and write the converse for this. All right, I write the converse. So this was my hypothesis that Ed lives in Texas, and my conclusion was that then he lives south of Canada. All right, and I didn't write the word then, but let's add that in there. Okay, then he lives south of Canada. So let's just flip those. Let's say, all right, well, my converse is going to be if Ed lives south of Canada, then he lives in Texas. So all we did there was we flipped the hypothesis and the conclusion. Then he lives in Texas. And is this true? Ed lives south of Canada? No, obviously this is false, right? He doesn't have to live in Texas. Maybe he does. Okay, maybe he does. But if we can provide even one counterexample, then this is going to be false. So in this case, it is false. We could use a counterexample. Let's say, all right, my counterexample is that Ed lives in New Jersey. Okay, Ed lives in New Jersey. All right, and you could come up with hundreds of counterexamples in this case, all right, as long as he doesn't live in Texas. All right. Now the biconditional. In some cases, the conditional and its converse will be true, and that's when we can write a biconditional statement. So we say if the conditional statement and the converse are true, and they have to both be true, we can write a biconditional. All right, and our biconditional is going to be written as P if and only if Q. P if and only if Q. This, whenever we see this if and only if, we can only use that for biconditional statements. P if and only if Q. So let's take a look. Here's a conditional statement that says if x equals 4, then x plus 2 equals 6. Let's write the converse. So I'm just going to switch these two things. If x plus 2 equals 6, then x equals 4. All right, so my conditional and my converse are both true. Therefore, I can write a biconditional. And I'll just say, all right, well, let's call this here P, this here Q. So I would write P if and only if Q. So x equals 4 if and only if x plus 2 equals 6. All right, this here is my biconditional. All right, let's try one more. If a equals 3, then a squared equals 9. All right, here's P, here's Q. Let's swap them and write the converse. So if a squared equals 9, then a equals 3. Well, you might remember this is actually false. Okay, and why is this false? Yeah, a could be equal to 3, but we don't know that it has to be true. Okay, we don't know that it has to be true. A could be equal to negative 3. Right, the square root of 9 is both positive 3 and negative 3. So a is equal to negative 3 is our counterexample. All right, so if they're both true, you can write a biconditional. However, if we can prove one of them false using a counterexample, then there is no biconditional.